So hello everyone. For this exercise, we are going to a different approach involving digitization of imagery from our Google Earth. Okay, so we are going to do some digitization. Okay, on imagery. Suppose that USGS is not working, we can use the imagery provided by our um, Google. So first, we have to download the Google Earth Pro. Okay, Google Earth Pro. We have to type it Google Earth Pro, and then the Earth version. You have two ways to do it. So you can search for the Google Earth on web, or you have to just download for the Google Earth Pro on desktop. There's a glitch in this one because some of our versions in our laptop, okay, has uh, this compatibility issue. Okay, so for those who has the latest one, okay, you can download this one. This is the latest one. Or if you want to or if this is not working with your installation, go to your installer page and download for uh, the mhm, for the previous version, so you can try this one. So I don't have to download for this one because I already downloaded and installed to my unit. Okay, so you have just to accept and download, and then you can now do you can open for this one. So I have already opened for this Google Earth Pro. This is the one. So uh what is being projected is my school. Okay, so this is the first that you can see. Okay, maybe we can launch it again. Okay, so there are a lot of opportunities, or there are a lot of ways how to digitize. You can digitize directly here. Okay, so this is our earth, the earth. So you can search for your place, for example, any landmark that you are looking for example, AIT Patomtani. It will give you a uh, options to choose. Okay, this is the international. So I would also want to search for the Mariano Marcos State University. We're in my own school. So once I search, it will give me this the area. This is the Mariano Marcos State University. So for this one, okay, you can first um, digitize this using path, okay, polygon, okay, okay, or path or line, okay, or a point, okay. Now, there's a lot of um, activities for this one. So first, I would like to teach for the second way, which is digitization or geoprocessing, georeferencing for JPEG for the image one. So first, I would like to take a picture for this one by using a snipping tool. Okay, and then I would like to take a picture for this. Okay, that's it. Or I don't want to take that. So I will just save this one, uh, and then name this as a tutorial. So Georef tutorial. Okay, so I will just name the image as MMSU. And now I have to open for this. Okay, it is a blank. So take note for this one. You have first set up the the GCS. First, we have to set up the GCS. Okay, and this. Okay, and we have to apply for this one so that we can use the degree, minutes, and seconds. And then let's open for the picture or the JPEG, okay, the image. Okay, so we are going for JRF and then MMSU. Okay, yes. Now, what is amazing for this one is that you can put a special attributes for this one, the lat and long. So we are just going to identify some um, uh, points, and we will put so a reference on this one. So first, suppose I'm not the georeferencing tool is not appearing in our toolbar, so just right click for this one and then look for georeferencing this one. Okay, so and then you can observe that this georeferencing is the chosen one is mmmshoot.png. Okay, now using this image with the help of this, we will identify a section. So for example, this section, okay, this location. So I will use this path, okay, and then put it here so you can observe that the latitude longitude changes. So first we have to do, okay, we have to go to here, okay, okay, yan. So it was already captured and we can zoom it. It will not change. That picture is this point. Okay. Now I will just use this section, add control points, and then choose it, and then choose the section that you want. We want to this one, and then right click, and then input DMS of long, lon, and lat. So for this one, we have lat longitude 120, okay, 32 and 69, 37.69. I'm sorry, 37.69. And take note for this. It's very important. It's east. And then for the latitude, it's 18. Okay. 3, 36.16. So take note for that's N. Let's change it into N. So right click OK. And then you observe that it gone. So this is the first point. Okay. Now let's move on to a second point. So maybe it's from the opposite one. Okay. So we will try to identify some points. So for example, this basketball court. This is actually a covered court. So this one. So maybe in the corner here. Okay. I usually choose only two because based on my experience, if we are going to use four, it will not, it will move. Okay, so actually the best number of points is four, but for output compliance, we can use two and then use it to compute for some area, for some. So it's a bit has a lower lower efficiency or accurately, but it is good to have a better output for uh, presentation, for example. So for this one, we are going for the second point. So we have to input for that longitude. The longitude is 120, okay, 33, 13.78, and it's east. Okay, latitude is 18, 3.25, 44. No. It's 325.44, and then it's north. So let's go on this one. So we can observe that it is now here. So we'll try to add the base map. Okay, we'll try to add a base map. So, and then for the imagery, let's add and let's wait. Okay, and then we will try to put a um how do you call this one? Oh, what's happening? It's uploading anyway. Let's wait for it. Uh, so you can observe here, no? So if I have to put a some mhm, uh, transparency so that we can see, you can see here that it exactly, or not exactly, but on the same location. Okay. Yeah. So we can also use the base map. No, we can also use the base map to to digitize, for example. Okay. This is the third way anyway that we can use to digitize our place. But the problem for base map is very it's always uploading. So the one of the solution is to put a JPEG into a another um a into a to provide a spatial attributes, okay, using um georeferencing. So don't forget to rectify this one, okay, so that we can have a save output. Now, you can observe here, okay, that it has already a values for this. Okay. So we can remove this one because this is the raw data. Okay. We can add and then uh huh? OMG. Where did it save? No. We have to resave it and then go to the tutorial and then we can rename it. Oh, I'm sorry. And just select the folder and the name is here, MMSUREC. So we will just put it rec, no? And it is in terms of TIFF. So now we are now having a data here. So we can remove this one, remove, and then we can have a uh, a data like this. That's it. So we can also change directly what we have done. So we can put it our the projected on our place. So take note for this. You should know what is the projected UTM, the projected coordinate system, and we will use WGS WGS 1984, and in our place it's 51N. Okay, it's 51N. For Patom Tani, it's 47N. Okay, so just click apply. Okay, that's it. So you observe that there's something happen. So for this one, we can create now and digitized values like areas, like something like that. So we can create here, okay, a folder, uh, and then or maybe direct, okay, and then let's say output or digitize output. So digitize output, so something like that, and we have to do some features, shape files, and we have to use it like for example polygon. Okay, we can use point, polyline, polygon for the ano, but I will do some polygons for this time. And we can edit actually for the projected zone. It's for the zone 51N for our place. So you should know what is your projected coordinate system. So let's put it. And then I will try to digitize for this one. So just right click for this one, edit, start editing, and then and then run. Let's wait for it. Okay, so this one will show the editor this. So try to look for this one and then click for this create features. Then click for this one and click for the area. So we are going to digitize so three colleges, okay, in our university. Okay, and then we are going for the right click open attribute. If you observe, okay, if you observe, there are shapes here. So I'll just stop editing and save the edited. So add for the area, we are going to solve for the area in float so that we can consider a decimal numbers. And then right click for this one and calculate geometry. So yes, so you observe that this is PCSWGS. So you can now solve for the square meter. So we can now compute for that one. That's if you want hectare, if you want square meter, etc. So but taran, you have now an area. If you want to add points, then you can add points. If you want to add shape roads, you can add path, okay, but the thing is you have to follow that you have to put to change the coordinates, the predicted coordinate system alongside with the GCS. You know what is the predicted coordinate system using the UTM. So our place in the Philippines is zone 51 and the Pathum Thani Thailand is 47 and so and this is now ready for presentation. So thank you everyone for listening and bye.